Okay. I don't even know if we're doing this on the right.
There are quite a few times.
All right, we're gonna watch this.
Years ago, researchers from the University of California,
Trying to
Davis
figure this
conducted
out.
a study of tens of millions of trade.
There are quite a few times where KiCad default footprint access it from, and I want this footprint to be available only on the editor has tools and app editor, because the footprints will reflect editor to create folder. Just like how we open the symbol editor, we can do the same for the footprint editor. You can either click on the footprint editor icon from the PCB editor, or you can directly access it from the KiCad's project window. This footprint editor has tools and navigations that are very similar to the KiCad PCB editor, except we have all the footprints that are available on KiCad arranged here alphabetically. To start, we'll create a new library just like how we did for the custom symbols, so this way we don't mess up the default ones. Go to File, click on New Library. And I want this footprint to be available only on this particular project, so I'll select the project option and then click on OK. Now while naming, I'll try to use KiCad's naming convention, so the name of the library will be something like cellholder_txt. This is not mandatory, but trust me, it will help a lot while managing a huge amount of custom libraries. For now, I'll just click on Save, and then we'll select the created library, and then click on Create New Library using this icon. And I'll name the footprint as cellholder CR2032.
Yeah, I don't think we did that. Let's back it up here. Back it up. Oh, come on. Did we? Okay, we went here. Right? Okay, so we did this. I don't know why that other part of the screen was gone. And then we made this. All right, you know what we're gonna do is we're gonna quit this. We're gonna go ahead and delete it from the file. We're just gonna start over just because why not? Okay, so that's not gonna be in there now. We're gonna start over because why not? Why not?
And then click on,
And it's still here. Still here. It's not supposed to be in here. Did we not delete it? Like, what am I even supposed to call it? Like an audio amp? Audio module? Cell holder. So what do we call this? We're gonna save changes. I don't even know what this is. I don't even know why that's up. All right, and there it is. How is it still in here? Oh, you know what? Okay, boom, gone. Now it's gone. All right.
Create new library using this icon. And I'll name the footprint as simple lot while managing a, and then click on. To start, we'll create a new library just like how we did for the custom symbols. So this way we don't mess up the default ones. Go to File, click on New Library.
I did that.
And I want this footprint to be available only on this particular project.
I'm going
so I'll
global.
select the project option and then click on OK. Now while naming, I'll try to use KiCad's naming convention. So the name of the library will be something like cellholder_txt.
So I don't know what to call this. We're just gonna call it amplifier audio IC. THT. Should probably put a big custom in front of it so that way we specifically know that it is a custom one. I think I like that idea more. So that's that. Right? That's actually, I like that because then we can find all of our custom ones all under custom. Okay.
This is not mandatory, but trust me, it will help a lot while managing a huge amount of custom libraries.
We're going to go through this part.
For now, I'll just click on Save. And then we'll select the created library.
If this becomes hard, we're just going to download the one that we found.
Create new library using this icon. And I'll name the footprint as cellholder CR2032.
Oh, do we?
And make sure the footprint type is through hole. CR20. Create new library using this icon. And I'll name the
This is not through hole. This is actually surface mount. So we're gonna put SMD. Can we rename this? Son of a gun. Can we rename this? How do we delete things? This is rough. This is rough. Okay. Manage footprint libraries. This is under probably at the very bottom. And we are probably, can we rename this? We can. That's a good sign. So this is a surfaced mount device. I don't even know what the D stands for. It is surface mounted. So, okay, we got that out of the way. Boom. We're going to delete all these things because we don't need any of those. All right, so we're going to create a new library, right? Did it? New footprint? New footprint. Discard changes. All right. Why does it not look the same? Anyways, we're going to call this something DA 7202. How fun. How get this out of the way. 72-00 UH2. And I
print as cellholder CR2032. And make sure the footprint type is through hole. And then click on OK.
So it did not give us that option. So we're going to press E, component SMD. Cool. Bam!
With this, we have the library setup. Make sure you change the grid size to 10 mils to make the drawing more precise. Now with this setting,
10 mils. Okay. $10 mils? I think we needed it like hella small.
let's try to draw a shape of the PCB with proper dimension from the datasheet. Now I'll just move these values aside and make sure the front silk layer is selected and select the circle tool.
The what? F silk screen is selected. That's good to know. I don't think I was selected on that last time.
And I'll draw the circle slightly larger than the diameter we need. So I'll make the radius slightly larger than that's required.
So, you know what? I think that's that 5 mil that it was talking about. So we're just going to make these 5 mil more. All right, so the up and down was 1.54. So then I guess we go to 2, 4, 2, 4. And then the other one was, so we're going to go to 2, 4. And the other is 1.83. So 5 of that would be 2.33. So we're going to go to 2.33 on the x-axis. Boom. And 4 here. Bam. 5 mil. Bam. E is to do edit. We're going to probably leave the... Yeah, that's fine. Of course, that is no longer in the middle. So we're going to go ahead and try and select that and drop that down. Oh, wait a minute. Where's the middle? Place the footprint anchor. Bam!
This will make sure the silk layer is visible even after we solder the components. Once that's done, we'll go to the circle properties and change the thickness to 0.15, which is recommended by the KiCad convention. Then click on OK. Next, let's add some paths so we can place the components on the footprint and solder them. For this, we can use the path tool. And then click on the places where we need the paths to appear.
Aha, did you see
Paths
that?
so we
It's
can
down
place the
here.
components on the footprint and solder them. For this, even after we solder the components. Once that's done, we'll go to the circle properties and change the thickness to 0.15, which is recommended by the KiCad convention.
0.15? Oh, this thing's gonna be bigger than the freaking thing itself. Jeebers. All right.
Then click on OK.
Wait. Silk screen line width is between 0.10 and as per A. Silk screen line width should nominally be 1.2. And 1 is allowed for high density designs. All right, we don't have a high density design, so we don't really.
Next, let's add some paths so we can place the components on the footprint and solder them.
So I did notice that this is the F courtyard is selected. So we're gonna go ahead and select that to make sure.
For this, we can use the path tool. And then click on the...
And so we're gonna go ahead and click on that. Wow. Okay. I don't know how that's gonna work. But it is a lot and it is really big. And we'll just have to figure these out in a sec. Because that is completely not the same. Oh, okay. So then we got to figure out what the diameter is of these, right? ball diameter 0.3. Ball. I don't even know what this means. What is the pitch? You know what? This is just how we have to do it. We have to learn everything. What does pitch mean on what? Ball dash bump pitch. Bump pitch. Ball or bump pitch is the distance between raised metal regions on the semiconductor package. The pitch can range from coarse 50 microns or 500 plus microns to very fine of less than 50 microns. I don't understand what that means. I mean, like I that's crazy because I don't know what I'm supposed to do at this point. I just want to know what the size is, man. Point 3. I think that's what we have to go with. Seating plane. Edge ball center to center. All right, we're going to try to go with this 0.3. Boom. Then we're going to delete these. Not this. There we go. We're getting somewhere. I'll drop that in the middle. Gonna do another one, another one, another one, another one, another one, another one. Boom. So we know the middle one is middle.
Places where we need the pads to appear. And always remember, the pad 1 should be on the left side of the footprint. KiCad uses the pin information to associate the schematic symbol with the footprint during footprint assignment. So make sure the pad numbers and the pin numbers match each other. For example, if the battery symbol have positive on the pin 1 and negative on the pin 2, the footprint should have positive on pad 1 and negative on pad 2. We need to be very careful at this stage so this doesn't mess up our entire circuit.
Forget Harvard. You can still manage other people's capital without an Ivy League degree. The prop firm model is making this happen. Prop firms gather capital to fund traders like me.
All right, so from the bottom view, so we know all the 2s are in the middle, right? EE 0.5. So here to here is 0.5, which means that to that is 1. So E1 should be 1. All right. So we'll figure out the distances
I place the
soon.
pass just eyeballing it. But we need to make sure it's very accurate. So I'll use the data sheet along with I'll use the measure tool and the dimension tool to make the placement of the patch very precise.
Okay, this is the measure tool. And so I believe it's middle to middle. I don't understand how to do this. I have no idea what's going on. Don't really know how to do this. So let's try again. Boom. So then can we grab this and move this? Boom to that. I like it. Right? So here to here. Okay. And we're going to grab this. Wait, what the heck? What the heck? This is rough. So from the top view, so if we were looking at this, A1 is going to be over here to the right. So I just want to go ahead and name that now so we don't freaking flip out. And now I kind of feel like we should just go ahead and download the one, but I really want to get this. That's rough. Okay. So A1 is in this corner over here. Because right, this is top. And A1's in the corner, so A1 would be down there if we were to slap that down right there. So that is going to be A1. And from what I understand now, is this should be on the x-axis minus, well, actually plus point beautiful. Beautiful. All right, so that's where that is. And so B1, which should be over here, What is B1? Oh, you know what? I could actually do this from here. Right? So if we add, so that'd be 6, 2, boom. And then we could just make sure that this is 0. Bam. This is way easier, like, right? Because, like, at this point, this should be exactly, which is what it is. Perfect. Now we got it. And so we know that these are all, so D1 should be 1 mil. So from the axis of 0, this will be negative. So we're going to minus 0.12 millimeters from 5. So that should be 3.8. And what we're going to go ahead and do is we're going to run calculations, even though we know for sure that's what it is. So that minus 0.12, which is 3.8. And we're just going to go ahead and make sure on the other side as well that, I mean, obviously if we plus those, that should be 6.2, but oops. You don't want to send this off to get made and things be wrong. All right, so that is the package right there. That's what that should be. So we're going to go ahead and do 8. And then this is B3. And then we can go over here and we should be able to that's actually pretty interesting. So C1 should be on the position of 0.62 still. And that's to actually just be negative 0.5. Boom. Probably rotated it a bunch of times, but it is -5, which is cool. And then x-axis should be 0.62. No. E. So this is C2. It's a lot of work. A lot of work. 0.12. This is C3. And what did we say that this was? 38. And Z-axis should be 5. Boom. I like it. We'll go to E. And again, the position is 0.62. And this should actually just be 0.5 this time. Right, let's just make sure. Oops. 0.62. 0.62. Cool. All right, and then this is A2, and that is going to be the 1.2, and that is the correct distance there. And then this is, I keep rotating these things. I don't know that it makes a difference, and I hope it doesn't. All right, so this is negative 0.38, I believe, and that is 5 millimeters down. Boom. Let's go. I think that's it.
Now with that done, I'll try to make the shape very similar to the component. So first let's add the excess part over here. We can easily do that by using the line tool. This circle can be a little annoying because we can't get rid of this excess part. And KiCad also does not provide a trim tool where we can just delete this particular section.
You know what I kind of want to do? I don't know if this makes a difference or not. So we're going to go back to the silk. And then we are going to go ahead and make another box. And what I would really like to do at this point is make one that is the exact dimension, which is 5'3" and 7 what? 5'4" and 7'3". .54 and 173. 7354. Boom. Then we're going to go ahead and make this line super small. I don't know if we're allowed to do that or not. And then we're just going to go ahead and find the middle of that. Oh. I don't like that. I think that changed what the middle is. I don't know what we're doing now at this point. So we're just going to grab it and drag it to see middle. Have no idea. Okay, well maybe that wasn't such a good idea. Oh gosh, come on. Like, so how do we find the middle, you know what I mean? Boom.
Instead, we can use the arc tool to recreate this curve. So I need to follow. And here under pad shape, click on rectangular. While we are under the settings, you should also make sure under copper layers, all copper layers are selected and both front and back copper mask is selected.
Okay. Confused. I don't know what that means. Warning, SMD pad has copper and mask on different sides of the board. Oh, you know what? These aren't through holes though, so probably just going to make sure that they're the same. F paste and F mask. F paste and F mask. Okay, we're just gonna leave it there.
Then click on OK. These settings were not mandatory, but it will help us create a footprint with very minimal design error. Now there is only one last step remaining to complete the footprint, that is to add some courtyard to the footprint. We can do this by selecting the front courtyard and then using the arc tool again. We'll draw the curve with a clearance of 10 mils from the silk layer. Then I'll use line tool to finish the rest of the graphics.
10 mils? 10.
Of 10 mils from the silk layer. We'll draw the curve with a clearance of 10 mils from the silk layer.
So it's 9/8.
We'll draw the curve with a clearance of
So it's got 11, 6, 10 mils. Oh, we know what 10 mils is because it says it right up here. .254 millimeters. 0.254 millimeters. All right, so we got the courtyard. And you got the arc. I don't know. What we're gonna do is go by center. So 0, 0, and 10 mils. So if this was 0.2.03, or what are we at? Actually, .2584. .2294. Bam.
of 10 mils from the silk layer. Then I'll use line tool to finish the rest of the graphics. Now to verify that the footprint has been included into our PCB layout library, we can go to the PCB editor, click on Preference, and then click on Manage Footprint Libraries.
Boom, saved.
And under this, if you go under project specific library, we can see the custom footprint that we created, that is cellholder_txt. Now let's see how this custom footprint will affect our PCB. I'll just click on OK. Let's select the cell holder footprint, then right click, then click on change footprint. And here make sure change selected footprints is checked, and then under new footprint library ID, click on this icon and
So then I guess if we wanted to insert it, right, how do we do that?
and then under new footprint library ID, click on this icon, then right click, then click on change footprint. And here make sure change selected footprints is checked, and then under new footprint library ID,
How do I add one? See if we can't. See if we can, yo, Skin, what's going on? Sweet, what you eating, man? Trying to figure out how did I get to that point where I was trying to add the footprint? Oh, no footprint assigned. I'm all lost, man. Tacos? Lucky. Lucky. I want tacos. Oh, preferences. This is where I was. I think. Nope. Symbol properties, sweet. Okay, let's remove that before we screw something up. Oh, here we go. Here we go. All right, let's save that. Let's go back to the editor. Biting arrow first. What did you do? Still no. No footprint. What? What do you mean? Okay. So now, what if I go ahead and insert my audio amp. Boom. Save. What? What are we even doing? Okay. Ah. Save. Okay, let's go here. We should probably dropping links. You could drop. Oh man, what was you trying to drop in here, huh? What do you mean A3 is not found? A3 is right there. So I'm guessing I shouldn't link them. Then oh, it is not found. Okay. Did I just disconnect and reconnect again, man? All right. It basically just says there is no connected pads, basically. But I think we're good. Beautiful. All right, so figured out how to do that. I think we're done
Click on this
there.
icon and search for cell holder THT. Then double click the cell holder CR2032.
I don't think we need to do
Finally,
anything.
click on change. You can see after few adjustments, we have successfully updated our custom footprint on the PCB.
We probably aren't going to get to that point, just so you know.
Alternatively, we can
We
also
don't
search
have the-
for
we
components
don't have the
online
3D models
and then
for it.
replace the footprint. Especially if you're using sites like Mouser, you can easily find the footprints for the parts that you purchased. But if you shop somewhere else or buy it offline, you can always end up using. I'll go to the Manage Footprint Libraries again, and under this, I'll click on this folder icon. And here I'll navigate to the folder and select the folder where we have the KiCad_mod file. In this example, I'm using 80tiny85 because that's what we downloaded in the previous video. It's not that bad, but I prefer some footprints. Have any questions or
Okay, so we're past that. What is next? What is next?
Welcome back to Master Tech, and in today's
So now let's get back to the original video.
welcome back to Master Tech, and in today's video, I'm going to show you how to take your breadboard hobby circuit components we didn't find. Make the electrical schematics. Start by adding some symbols relating to your physical components. And since I want to drive this project with an Arduino Nano, which I will mention is actually a PCB itself already, so that'll be the first thing that I look up when I press A to add symbol, or click the icon and search for Arduino Nano. Most stuff that you would commonly use in a circuit already exists. in
Okay, I don't think we
all
need that
KiCad
anymore, so we're gonna come back
libraries.
up
If you
here,
can't find it, chances are there's a link to
find the
KiCad footprint or
schematics.
symbol available from the manufacturer. If they don't, it's not too hard to make from scratch, but that's enough material to be a whole different video. I'll drop in 12 LEDs, of which there are tons of types, and it doesn't matter a ton during the electrical schematic which you pick, because it's super easy to change later before finalizing. Then 12 resistors and identify them as 220 ohm. Then
Wait, what did he say?
12 LEDs, of which there are tons of types, and it doesn't matter a ton during the electrical schematic which you pick, because it's super easy to change later before finalizing. Then 12 resistors and identify them as 220 ohm. Then what I actually want for my servo and capacitive touch sensors are pins and sockets. I want ports ready to go for me to connect my components to them, but I'm going to be installing this in a larger box where I'm gonna have the capacitive touch sensors and servo a little bit physically spaced away from the PCB. So I just want pins and sockets to easily land my stuff on. I don't want to have my capacitive touch sensors or servo physically embedded in the PCB.
That guy is going like hecka fast. Sweet. So what's next? I guess to add all this stuff, right? Seems kind of crazy. I'm waiting to log in to my DigiKey. Oh, here we go. We could probably just grab the orders right here. Let's go with So we'll just start right here, I guess, right? We'll go with B1. So C6, so capacitor 6, which is at 22 or 220. Let me see if I can find that. 220 UF. We've got the DigiKey part number. So we're gonna go ahead and try and add. And I already forgot how to add. Okay, so we're gonna find. Do we know if it's polarized? I don't know. I don't know. All right, let's just go to capacitors, if there is that. I don't see that because it's all under devices, I guess. Dude, how am I gonna find these? This is ridiculous, and I can't even log in. Oh my gosh! Finally got me there. We're also gonna go to Mauser. I guess we could do that here as well. So we're gonna go to Mauser. I hate this because they make you do this before you can actually click on anything in here. So the manufacturer's part number, which is here, bam. Oh yeah. We got the whole thing. Actually, don't know what we're supposed to download it in. Oh, 3D format. What is the 3D format supposed to be?
Get a final expert review
Is
before
there
you
a-
file at no extra charge with TurboTax Live Assisted.
I'm done spending an obscene amount of money.
There is not. So I guess we got to find out what. There's so much stuff to do. 3D model format. Models in WRL and STEP. WRL files are used for realistic rendering, while STEP files are used to integrate with KiCad software. Okay, so I guess we will use STEP files. Question is there's two different STEP files, so which extension? Are we looking for? let's go to graphics, and then we'll go here. Okay, that's not helpful. Okay, well, .stp or .step. This is dumb. I hate when they do this. For a KiCad, the preferred 3D modeling format is .step or .stp, as they are essentially the same. So are they the same, or are they essentially the same but a little bit different? Because usually when you say that essentially they're the same, doesn't necessarily mean they're the same, and there wouldn't be a reason to have a difference. But since this is in parentheses and that's the or, I'm going to go with the dot step. And that is what we're going to go ahead and do. See what happens when we press download. We have to have a Mauser login. I guess we will create an account then. I don't know what my username is. Is my username my email? If that's the case, why not just say that? It is. Okay, so we downloaded those. And I guess we should have paid attention to that other spot, because now we're going to go ahead and import no. All right, so we're going to go to our downloads folder. Boom. We're going to go ahead and extract this to here. How to use models. let's see. What does it say? Okay. So at this point, we are going to manage an existing oh man, I really screwed that up. That was supposed to be saved in my other spot. Okay, so I guess we got to go back through the other video.
There are quite a few times where KiCad default footprints, but if you shop somewhere, we have already downloaded the part from the Snap EDA in the previous video. We'll just see how we can add that part here. I'll go to the Manage Footprint Libraries again and then replace the footprint. Especially if you're using sites like Mouser, you can easily find the footprints for the parts that you purchased. But if you shop somewhere else or buy it offline, you can always end up using third-party sites like Snap EDA or Octopart. Since we have already downloaded the part from the Snap EDA in the previous video, we'll just see how we can add that part here. I'll go to the Manage Footprint Libraries again, and under this, I'll click on this folder icon.
So we gotta look for symbols. Here it is. Oh, there it is. What else is in there? What if I did that instead?
Good morning everyone, and welcome to today's tutorial. It has been 10 days since we posted another video about designing in KiCad. Here, this is it's downloaded, so you can copy it. We show you how to again. We can extract it. Yes, let's run the project so that we can 6913. 6913. And upload our the foot thing. So we can upload this symbol and then we see how you find it in KiCad. So when you want to upload, you can use this part, use preference. Still use this part and then you use preference and so on. But I would like us to use this other part like this. So we can use this other part for the symbol. You come to preference and then manage simple library. But you can also come back here and still use the same. We have preference again, and then you can manage symbol library and manage footprint libraries. But I want to upload each individually where we are supposed to upload them. So let's come here, we use symbol, we upload the symbol first, so we can manage symbol like this. Then you come and hit on this folder to add an existing library in your desktop that you have downloaded. Then you come to download. We have this one is a library that is existing here. Then we can select this one, then we can open the file. Then this is the library that we want to use. That's a symbol like that, and you hit OK. Like this here. Then you manage again. Let's see, is this, you place it where you want to use it like that, and then you can control save. So this is a symbol, but again when you come back here and try to check at the footprints like this, we check at the footprints, you can see your symbol has a footprint, yes, but let's see, does this footprint has a symbol? Or tap, you place it where you want to use it like that, and then you can control save. So this is a symbol, but and search again at your symbol to see 6913, you can see it's here. Then you double tap, you place it where you want to use it like that, and then you can control save. So this is a symbol, but again when you come back here and try to check at the footprints like this, footprints like this, we check at the footprints, try to check at the footprint.
So how do I add? Oh. Ah, we found it. Do you know what? I already forgot. Oh, here it is. Are you saying we're going to need to... Son of a biscuit. It's ridiculous. We're going to have to create a whole new footprint? Is that what you're saying? Is that what you're trying to tell me right now? Is it? That sounds pretty terrible. Well, interestingly, yeah, works. So why can't this work? Who knows? Anyways. All right, so we have C6. This is just redonkulous. We got so many parts to, I mean, we got not so many, but we have parts to go ahead and add. Let's go back to where we are over here. So we're gonna grab this. We're gonna go ahead and rotate this. I actually don't know what pad is what. But we'll go ahead and move that here. All right, so we're gonna place another symbol. So we're gonna add 2. Well, you know what? We'll do them at the time. Okay. Boom. And VLDO. What is VLDO again? We're having the most awesome time here. Okay, so VLDO is output voltage from LDO.
Welcome back to Master Tech, and in today's video, I'm going to show you components points to them, but I'm going to be installing this in a larger box where I'm gonna have the capacitive touch sensors and servo a little bit physically spaced away from the PCB. So I just want pins and sockets to easily land my stuff on. I don't want to have my capacitive touch sensors or servo physically embedded in the PCB, but I do want it to be simple. I could make all 5 the same, but this is also a good way to keep this going to be hard to keep track of. Making sure that all of the connections from point to point are accurate is the most important thing, and then when we build the PCB in the next step, you'll see the opportunity for prettying it up sort of shows up there, and that's a little bit more important. Now the last thing we want to do in the schematic editor
Okay. So I don't really know how to do that portion of it, thanks to the non Yeah, what are these endpoints? Like, how do we... All right, was there an LDO? This is it's driving me crazy. So is it a pad? So these are the pads. Oh, so do we have to create? So I guess that's the question. I don't know how we do this portion of it. Like, what is that considered? And do we got to use that as like a pin of some sort? Because this is not very helpful. This guy just runs right through it. KiCad 9.
In this series of videos, I'm going to be brand. So up here at the top, we're about 21. Click on this and hit escape on our keyboard. 5, and I'm just going to put this right there. So now, and we can zoom in with the mouse wheel and add in power symbols. We need to go up to the button right below the component. And you'll see after we place it, our mouse cursor still has a little symbol that removes Arduino. So to add in power symbols, we need to, that will open up this window here. And now we can just type in 5 and the letter V. We have our 5-volt symbol. Click on that. And we can zoom in with the mouse wheel and we can just place it like right about here. And we still have that symbol on our mouse cursor, so let's click it again. And this time we're going to type in GND for ground and click OK. And then down here, we're just going to put this right there. So now we just need to attach these symbols to the Arduino. So let's scroll back in and we have this 5-volt symbol here. So we can just hover over this circle, click, and then we can then drag a wire and attach it to this label right here. And we do the same with ground. We have 2 ground pins on the Arduino. So in VCC, I consider these the Arduino setup and wire a switch and a resistor. So opening back up the parts selection menu, we can just type in the letter C. First one comes up as capacitor. Let's click OK. We can place it on the board. Click again. Open the window back up. Type in the letter R. You have resistor. Place that on the board.
Wait, is all I had to do?
Again, to open up a 3rd time. And now we want to select a button. And to do that, we're going to type in push. And the first one here that came up is a push button switch. Click OK and add that to the board. Now we can click escape and now we can start wiring and moving the stuff around. Keep in mind though that this has added an unpolarized capacitor. If you need to place down a polarized capacitor, you do need to explicitly tell that to KiCad. So back in the symbol table, we would type in C and scroll down a little bit and we see capacitor polarized. So if we had a polarized electrolytic capacitor, this is what we would use instead of this, which we're using for ceramic capacitors. So let's zoom in on these 3 parts here. And first thing we want to note right away is that these components do not have any values. And these are just blank symbols. We need to actually tell it what they're supposed to be. So if I go to R1, click it, and press the letter V, V for Victor, on my keyboard, it'll open up this window where I can then type in a value, and this I'm going to say it's 1K. Click OK. Now the value has changed to 1K. Same for the capacitor. Click on that, press V, and type in 100N for 100 nanofarads. So now we just need to line them up properly and wire them up. So I'm going to click on the push button switch and press the letter R for Romeo on my keyboard just 1 time. It rotates it by 90
I wonder
degrees.
if I should do it that way.
Click and then drag it up here just like that. And for the capacitor, I'm going to click it once and then drag it right about there. Now we also need to add the power connections, keeping in mind what we've used previously, keeping them consistent. So back at the power symbols table, I'm going to click here and type in 5V, get our 5-volt symbol placed, put it right about there, and click again and type in ground and put it right about there. Now let's start wiring these up all nice and easy. Let's press escape to get our cursor back and then just hover over top of the parts where the pins are, click and then drag them to connect them all together like this. And the capacitor wants to connect between the switch and the resistor and the other end to ground like that. So we need to do this 3 more times, but instead of doing all that again, I'm going to just drag a box over top of all this. I'm going to move it over here a little bit, press Ctrl+V, get our right about, and put it right about there. R for Romeo on my key to 1K. Same for the capacitor, click on that, press V, and type in 1 to ground like that. So we need to do this 3 more times, but instead of doing all that again, I'm going to just drag a box over top of all this. I'm going to move it over here a little bit, press Ctrl+C, and then press Ctrl+V. And just copy everything we've done here, and I press Ctrl+V again, get another copy like that. And you'll see that the part numbers have automatically incremented, and it's now keeping track of all the different capacitors and resistors we have on here. I'm also going to take all this stuff we just made and move it down here, because we're going to need some space up here when we go to connect this to the Arduino. So now to connect them to the Arduino, we just need to connect each switch to D2, D3, and D4 respectively. And to do that, we want to, these are easy, you just go back to the R to rotate it, but I'm just going to add a wire 105. This is not actually the module. What we need to do is we need the OLED screen.
So I'm confused. How do we do this portion? How? Tell me. Tell me the secrets. Tell me the secrets. How did it know? See, yeah, how do we, what is, I just want this to be done. Global labels. All right, let's hope that that works. I don't know what it's doing. All right, whatever. So what we're going to do is go ahead and grab this. B3 is going to go up here. Beautiful. These are all going to go here. Then we're going to come over here, grab ground again, drop that in right here. Go back to here. We're going to drop this into there. Cool. And we're still not sure, but we're going to go ahead and make this one. Let's just, can we type this in? V power? Then we'll find out. Which one works, right? The only way. Dun 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 dun. Dun, 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 dun. All right. Find out if those are the same. Which they are. J6, J1, J2, 1122 ground, PDN. Six, 1, 2, PDN. It's a beaut. Okay. Let's move over here. And then we'll drop these in. I have no idea if these are the right thing. But we're going to call this PDN_N. Boom. It's fine. Probably drop that in somewhere right there. This one we're going to go here just because this is what we did on the other one. We want to make sure it's the same. These other ones we will use the bam. Move those over a little bit. All right, now we're gonna pads. Can we put pads down? Jumpers? Oh, they're jumpers. Is there just no J by itself? Good times. I like that. How do I get him to show up? Aha! There we go. So many things. Oh, is it junction? Actually, I think it's junction. Guess that doesn't have to. It's not it. All right. Well, we're gonna go ahead and put in. Hopefully, audio jack, 3-pole. Does your search function not work? Can't do a search for it. And you know what? I'm fucking fuckers. Unknown. Unfreaking known, man. So we can get step files, we can get the 3D model of it, but we can't get... That's ridiculous. Okay, so we have T, B, S, R. What kind of freaking... We had to buy these ones? Had to buy these ones. Couldn't buy different ones that has more info. the hardcore thing is, we go here. That's it right here. That doesn't even look right. Because that looks like a 3-pole. Or a 4-pole. Unless that 3 portion is just not really necessary. Aren't you supposed to label your pins? Like, right? Well, we were definitely hoping that definitely hoping we could finish tonight, but that is definitely not happening. That is for damn sure. Can we flip? All right, we're gonna roll with that. Guess we can't change the names of those. Ooh, do we want to? Okay, we don't really want to change that here. I don't think. Okay, we're just gonna leave it. We're gonna leave it. Leaving it here. Dude, that's not what I want. Or we're not gonna worry about it right now. What we are going to do is add I don't know what the difference is. Dang it. R1 short. was FB. Okay. It's interesting because it's like FB1 and 2 are unpopulated. Then it's like OR underneath, which is this, which is an open. But why do we have these? You know what I mean? Oh, here's the populated. By default, these are unpopulated, but we're gonna have them anyways. I like how it's like in a schematic, FB stands for feedback. In a schematic, FB can refer to a ferrite bead. So let's just go to the picture. Right here and right there. So does that mean those go through the board? Unless those are the feedbacks. Oh, it's 0R. Good times. Good times. Keep on rolling. Good times. Kind of cool. probably more like what it actually is. That's cool. Okay. I think we're gonna go with generic. guess we will deal with the rest later. Thank you for being here, guys. We finally got at least the schematic done. Tomorrow we'll probably do the footprint, and then we can try and get this PCB made. That would be cool. Would be awesome. Everything will be great. All right, that is it, folks. See ya.